So, what do we know about statistics? Just before we dig into this, what do we know? Anthony, what do you know about statistics, man? Like what? What stuff do they help us understand? What's one time you've ever heard of people talk about stats? Sports Center, right? So, if you're coming in late and you need 14.1, they're here. Oh, who's got the 14.2 extra?
I got the.
14.1 is 2 sets.
We'll probably move kind of quickly today, but I just wanted to get you guys all the notes so you had them. Just for the next couple of days. We won't go any further than 14.2 this week. I just wanted to make sure you guys had the stuff you needed. So Sports Center, right? What do they use stats for? Which team has what probability of winning or what chance of winning based off, how good they are, who they got on their team, who's injured that week, who they're playing. And that comes into a realm that you should avoid. But gambling, right? If you want to bet on one team, if they're set to lose and you bet on them winning, you could win a decent amount of money. Now, if you bet on them winning and they're already supposed to win, you're not going to win much money because, well, you're going with the predicted outcome. What are other ways that we use statistics? Anybody know? Anybody's parents do anything with statistics? Yeah? What is that? Yeah, how so? Do you know? Yeah, we could do statistical data on first of how people get their energy, like what providers or whatever. We could do data on how they're using their energy. Glenn?
My mom works at the hospital and she has to see who paid their medical bill or not.
So we could do statistics of who's defaulting on medical bills, which sometimes that's intentional. They're trying to get their insurance to pay more.
Yeah, it depends on the type of equipment.
Yeah.
Equipment costs a lot of money.
Kylie?
My dad works selling software. So
Yeah.
I'm sure he uses statistics.
Yep.
Anybody absent?
I'm not certain. I haven't even looked at the absence email, like the attendance email. I haven't checked. Here's what I'm trying to get at. Statistics is used for pretty much everything. What statistics is collecting and analyzing data. So my wife right now is taking a statistics class for her master's degree for health advocacy, where you collect information in the health field to advocate for healthcare providers or healthcare treatment centers or whatever. So we use statistics to interpret and communicate information out to people. And sometimes we can kind of manipulate the statistics to do what we want to do or to say what we want to say. So we have a situation here. We have a big issue with trash in our town. Stick with me, we're imagining. But we really do. There's trash all over. And the mayor vows to knock on every door and talk to every person to collect some ideas to resolve the trash issue. So, is this a good idea? Is this a bad idea? Why? Why not? So CJ, you very quickly, I just heard you say no. Why do you think this is a bad idea? There's a lot of houses, which means it's going to take a long time. Abby, I need you to raise your hand here. I love what you have to say, but we got a whole class of people. You can't just steamroll and talk over top of people. Okay? Love you. You're awesome. You got to respect your classmates. Justin, you had your hand up. Why do you think it's a good idea? Yes, sure. The mayor must care about us. He came and he knocked on your door and your door and your door and your door and your. He didn't make it to you yet, but he only made it so far down the street. So maybe tomorrow he'll get to your guys' doors And maybe next week he'll make it to you guys. And well, I agree it could be a good idea. It shows that he cares. He's going to get a lot of data. But are we paying the mayor to knock on doors? This is where statistics companies come in. He could literally hire out this job to a statistics company, which is kind of what Worthington is doing right now. Anybody in foundations on this side here, Mrs. Goldring, talking about the facilities planning that Worthington is doing right now, trying to figure out what to do with all our students and our buildings that are kind of, we need to improve our buildings or build some more buildings.
Mm-hmm.
We hired a company that does work with statistics. They're called Dijon Richter. The district hired them to collect data. So we would not want to knock on every door. And even if we want to knock on every door, we would not do it ourselves. We would hire it out. Instead of knocking on every door, though, we could take a sample. So now it comes into vocab. So now we got to write some stuff. So everybody, pencil, pen, something ready to write. The population is everyone. It's the entire group. Whatever you're looking at, it is literally everyone. So everyone in the town, or everyone in the school, or everyone in the grade, whatever it is you're talking about, it's the everyone. The sample, anyone have ideas? Abby?
Maybe the sample is like what you're trying to get people to do. Like, or
Quite.
like what
Michaela?
like a group of something.
Yeah, it's a group from the population. So it's a group from, and you can abbreviate the pop. It's a group from the population. So the sample is not everyone. It's just a smaller group. And then a subject.
That's what the sample is like identifies as.
What do you mean?
Like, you have to have 2 parts to statistics, or like 50% of people. Like,
So that would be like what you're trying to communicate. That would be after you've collected all this. If you're making like percent statements, that'd be after everything. Hayden? No. A subject is one member of the sample.
I just remembered.
Sorry, my smart board's being weird this morning. That's a T and that's an, well, that was supposed to be an L, but now I'm just going to rewrite that. It's like bending some of my letters. So subject is one. Sample is group. Population is everybody. Any questions on that? So you've got a little visual here to help you remember that. If this is my population, my red, my entire circle, we're talking about whatever this is. The sample could either be the purple group circled here or the blue group here. I've got 2 different samples. A subject, this guy's a subject, that guy's a subject, that dude's a subject, that dude's a subject, that dude's a... Each individual person is a subject. Abby?
Like, this is like just kind of like just helping me like remember. So like the subject, like one like person from the group, isn't it? Don't like I know like I'll be like watching things and they'll be like, here's the subject. Like they're not talking about like here's like the theme of this. They're talking about like here's the person that's gonna explain everything. Is that why they call the subject like one person?
So they are being subjected to a question or a treatment, or so they're the subject because they are the subject of a question, an experiment, or whatever. That's why we call them the subject. They are subject to, or they're the subject of. Yeah, so that's where that word has another meaning. So we're investigating the lengths of all words in a book. We decided to get really nerdy. So I need you to identify, is this a sample or a population? Is it a group or is it the everything? And if you think it's neither of those, is it maybe a subject? So take a moment. I'll use cards. Bring it back together. If you get done with this example, move on to the got it, and you're doing the same thing. It says which are samples. Ignore their question. We want to identify, is it a population? Is it a sample? Is it a subject? So we will notate what it is for each of these. I don't have any questions. So you have to look at the question that you're asking in a book. So words in the book. The question kind of tells you. So, Casey, if we look at all of the words on a page of the book, do you think that would be the population or a sample? That'd be a sample because population is kind of told to us, and we'll get there in a second. But that's a sample. If, Lily, we look at every other word in the book, yep, we're just alternating, we would get a larger sample there, and that would be a pretty good distributed sample because it would cover the whole book. Maylee, what about all of the words in the book? So let's look at the question. We're investigating lengths. Wow, that's off. Lengths of words in a book. So this would be like asking a question, I'm investigating ages of Phoenix students or musical choices of Phoenix students. So the of kind of tells us what the population is. So when we look at all of the words in the book, that is actually our population. It's off. It's got pixels that are dying, and it's therefore bending things. So please make sure you have that. That is the population. Justin, what about one word in the book? That would be a subject because it is only one of the items in the population. Yeah.
So if those two would be a sample?
Yep. It'd be a really crappy sample, but 2 words would be a sample. Yep. It's only a subject if it's a single.
I like to be a subject.
So, let's just run through these, even if you haven't had a chance to get to them. Julie? Sure, yeah, first one. Every other t-shirt in the store. That's a sample, right? It doesn't have every one, but it doesn't have only a single. You can abbreviate if you want. Yeah. All of the t-shirts in the store, Anthony? Okay, so it's the population. If it's all of them, it's the population. Andrew, what about, all the medium shirts?
Unless you were only selling all medium shirts, it would be a sample.
Yep, that's a sample. Now look up at the problem. It tells you what it is you're looking at. You are studying the t-shirts being sold at the store. So it doesn't say anything specific about size. Doesn't say anything about specific style. You're just studying the store shirts. Jack.
Yeah.
One t-shirt in the store? That would be a subject. And Reagan, what about all of the striped t-shirts in the store? That would also be a sample. Any questions for how we're doing any of this? Cool. This is why I thought we'd probably get into 14.2 potentially today. Should be able to move fairly quickly. So, you should know about this. What is it that gives you personal preference one way or the other in a certain situation? Flynn? Bias. Now, let's have a little conversation here. I'm going to calibrate my board while we talk. Is bias a bad thing? Now realize this is not a simple question. Is bias a bad thing? So think about it for a moment. Hayden, what do you think? Is bias a bad thing? Why? Ooh, so...
Good morning. Seth Anderson, please come to the office. Seth Anderson to the office, please. Thank you.
you have a lot of biases that are good things. Yeah. So your personal bias towards sushi is kind of like meh.
It depends.
Ooh, I don't really care about how you feel about sushi. But you do have some biases that, quite frankly, are keeping you alive. When you have to walk, like say from here to home, where do you normally walk? On the sidewalk. Why?
Because you don't want to get hit by
You could walk on the grass, you could walk on the street, you
Yeah,
could walk
you
in the
get
middle
hit
of the
by a
lake.
car.
But you have a bias towards walking on the sidewalk. I didn't say on, I said in.
Oh, that would be
So-
swimming then.
So you have lots of biases. Now, when we talk about bias in the sense of data collection, here's what we're really asking about. We're not really so much concerned about do you as an individual have a bias. We're concerned about is the question being asked a biased question? Is the group that we're asking it to a biased group? So if I wanted to know what sort of music I should play at my brother's wedding, I'm DJing my brother's wedding in about a month,
Yeah.
and I ask you guys, do you think this group has a bias? Yes. Will that affect the data that I collect?
Yes.
Yes. That is probably a poor choice because what's the population I'm going to be DJing for? Like, well, adults, right? Like, not kids. There's no kids allowed. So, it's just the place that we're at. There's just no kid policy. So, biases can be okay, but it all depends on does it affect the data that you're collecting. So, let's look at the guide. You are collecting data on who goes sledding each year. So the question we're asking is who goes sledding each year? Now we can't even say we go sledding each year because did anybody get out to sled this year?
Yeah.
There was like one snow that it was enough snow to go sledding. But you, well, okay, that when you go to the mountain, that doesn't count. That's I'm
Well,
talking.
I went-
Well, I guess I can't say that doesn't count. But yeah, you were able to go on the slopes, but we not necessarily. So let's talk about does this have bias? So Kylie, if I'm asking, do you go sledding every year? And I ask everyone in Colorado, Utah, and Vermont, do you think that has bias? Why do you think that has bias? So this has bias because of what? What's the cause of the bias? Yeah, but you said where, right? Where they are. So this is bias from location. So that just the location of where you asked the people gave that the bias. Aiden, what if we asked 200 people from each state? Yeah, does that have bias, do you think? No, because some states are colder, some states are warmer. We're gonna get a merged sample. So like that 200 people from each state, that's not everybody, so that's a sample, but that would be fairly unbiased. So that'd be relatively fair. So we could just say this is fair. Grace, what about everyone in Florida, Louisiana, and Texas? Do you think that has bias towards the question of do you go sledding?
Maybe not because Florida, Louisiana, and Texas are like warmer.
So if we're talking about going sled riding, do you think a warmer climate will bias their answers? Yeah, right. Again, we have a location bias.
Well, that would just be a stupid question.
Yeah. So this is the same bias as above for location. And you don't necessarily have to know why, like, you should know why the bias is happening. You don't necessarily have to write it out. A lot of times we'll just ask you, is this biased or not? And then, Bella, if I'm asking everyone who owns a sled. Yeah. Hello, you own a sled. Of course that's biased. and you asked the question, this is a question bias. Because if you are only questioning the people who have a sled, you've already biased your results. If I ask people what their favorite sport is, and I go ask the basketball team, that is giving it a sport bias. But if I go ask the chess club, okay, that still probably has some bias away from sports, potentially. There's a lot of really good chess players who are really good athletes. But that is not directly a sports question. I could even further get away from bias by asking like a group at lunch. There's no bias if I just grab a group that has nothing to do with sports. Or if I stand at the front door and ask people randomly as they come in. So this group below, and I apologize, I don't know who decided to make this, and they grabbed like the female icon that looked like she was pregnant. But yeah, normally people get angry. Yeah, I know. People are like, what? Why? So I will apologize for that now. I did not make this. It's an image that I gathered off the internet. Well, actually, I got it from Pearson. Huh? Yeah, I know. They're the normal ones down here. So these represent the icons. These represent the same thing. These red female icons represent the same thing as here. I don't know how they ended up. Actually, they've got their winter parka on. They're ready to go out in that cold sled weather. So, hold up. When we talk about collecting a sample, this is where we decide whether or not it's biased and whether or not it's representative. I don't know how deep to get on this. Anyone know why we have a House of Representatives? Like the House has a bunch of guys in it, right? The Senate only has 100. The House has 435. Ohio's got some reps. Glenn, why do we have representatives?
To make choices for us, because like we can like present laws like, can we own like 5 cats in our home, and then they'll like decide on it.
So I agree. They make choices for us, but based on what are they supposed to be doing? Based on based on us, right? They're supposed to represent us. We are the population. Our representatives are supposed to represent us, our ideas. So, if overwhelmingly, let's take your cat law, if Ohioans overwhelmingly do not want people to have more than 5 cats in their home, but the representatives are like, yeah, we love cats, let's have cats. That is not representative of us. If we as Ohioans, like 80% of people want to say no to the above 5 cats. So you have to match the population. So the representative sample, please highlight this. A representative sample is proportional to the population. So the representative sample is proportional to the population. So how that sets up here is we have 12 females out of, so if I say female, it's 12 out of a total of 16. Well, that reduces to 3/4. If I look at my female down here, that's 6 out of a total 8, which reduces to 3/4. They reduce out to be the same, which means they're proportional. A biased sample is not going to be proportional. So if there was one thing that I would say to highlight here, I would highlight the not proportional. So that proportional, or that sample skews your data from what the actual population is. So we saw that female up here was 3/4. Down here, if I look at female, it'd be 4 out of 8, or 1/2, or that 50%. That's not the same. It doesn't match. It is biased. It is not proportional. What don't you understand?
Well, so why is it if it's like 1/2, it's not the same, but if it's
Because in our population, we see this is the actual group, there are more females than males. And if we take a sample that has equal males and females, these males are actually going to have more effect than they should, because they're now getting 50% of the like vote, the say,
People are gonna, like,
when they should only have 25% of the vote. So if we're like making decisions for like school lunches or things like that. So let's move on to this. So ... If we were asking Phoenix, let's say we want to ask a question of, should we have an after-school canteen in the spring?
Yeah.
So let's say that's our survey question. That's our statistics that we're collecting. What would need to be true about our sample to be representative of our population? So think about some characteristic traits. If we're asking, our population's all of Phoenix.
Wow.
Grace?
It couldn't be even with males and females.
Are you saying it needs to be or it should not be?
It shouldn't.
To be representative?
Representative
So to be representative, it's got to be proportional. It's got to match the characteristics. So one characteristic that Phoenix has that we're all very aware of, Andrew, you had your hand up.
Oh, I know.
Maybe grades?
Yeah. What about grades?
Like 7th grade and 8th grade?
How much of the population is in each?
I don't know.
Well, if we take, like, we try to take 80-ish 7th graders and we pass you all on to the 8th grade. So relatively, we'd be pretty close to 50, 50, 7th, 8th. So we should have about 50% 7th grade, 50% 8th grade, relatively. There's actually slightly more 7th graders than 8th graders, but we're really close.
Then why is the 50% females, 50% males?
This was not Phoenix. This was relating to this population up here. This population is not evenly split. Our population in Phoenix is evenly split.
Well, pretty much.
Now, another characteristic trait of the Phoenix population, Abby,
Wouldn't it be like the teachers to students?
we're only looking at like students. We're asking the question of Phoenix
Wouldn't it be, like,
students.
voice? Like the amount of voice that people have? Like,
Yeah, but who do we need to ask? What does our sample need to look like to represent the population? Izzy? Yeah, so that's our 50-50 7th, 8th. That's 50% 7th graders, 50% 8th graders.
the same amount of girls and boys.
Yeah, we need 50-50 boy-girl. If we're gonna be proportional, we're gonna represent, we got 50-50 boy-girl.
Your sample?
Yeah, so like, if our sample, so then we take this a step further and we say, okay, if we're gonna ask, let's say 20 kids, then we would know 10 should be boys, 10 should be girls. Of those boys, 5 should be 7th, 5 should be 8th. Of the girls, 5 should be 7th, 5 should be 8th. Then we'd have even 7-8 split, even boy-girl split. Make sense? We're going to match up with the population. We're not as big, but we're going to represent what the bigger population has going on. Questions? All right, let's check this back.
It's so pretty.
So, making inferences or making predictions. I can only make a valid, what's it mean to be valid? Valid mean if it has validity. Something has validity. Or somebody says, you're invalid. Really? Is Abby the only one awake today? Is he? It's correct. It's right. Yeah, it represents valid means correct or right, or with evidence to back up. So, a representative sample. Assuming the sample is representative, that means it's good, it's valid, it matches the population. I can make predictions. So if 25% of let's say the sample has 40 people. So 25% of them have characteristic X. What's 25% of 40 people? What's it? We had 10, right? So that'd be 10 people. If my population actually has 200 people total, how many people would we think would have characteristic X? 50, because that would be our 25%. So that's how I match it up and make it proportional. This is 1/4. This is 1/4, if I reduce it out. Now, a biased sample doesn't work. So that's where things get screwed up. If I took a sample that wasn't representative, it was biased, it's not going to give me an accurate prediction, because let's say here we still had those 40 people, and this predicts 45% of them. That's almost 50%. That's probably going to be like 18 or 19. So let's say 18 people have this characteristic, when out of the 200, there's still actually only 50, and that would not equal, this would actually turn into 45% and be like 90, it'd just be 90. So their prediction would predict 90. When we actually look at it, we get 50. These are not equal, so this is not valid. So their predicted value does not match the real. It is not valid, or it's invalid. You know, in means not. Questions? Essentially what we're saying is, if you know your sample's biased, trash it. Don't use it. Don't try to do anything with it, because you'll get incorrect results. And if we are 200 years in the future, let's just imagine you go into hypersleep. Somebody somehow cryogenically freezes you.
Yeah.
Don't know if you'd like that or not,
Happened
depending.
in America.
And you wake up and you see these 10 beings. So you got 2 little robo dudes and 8 kids, actual babies. So we're now coexisting with AI, artificial intelligence. So let's say whether each of these is a valid inference or not, based on the sample that we see, and we know that that sample is representative. It is a good sample. So could we say, Joe, are we able to say that 20% of the population are robots? How? Yeah, so we have how many robots? 2 compared to how many total beings in the sample? 8. So it's that was 8 kids. If we talk about the total, that's 10. So my robots here are going to be 2 compared to 10, which is 20%. So we could say, yes, this is valid because it matches my sample. That is a true inference. There are more humans than robots in the population. CJ, do you think that's a valid inference to say? That there are, yeah, because we've got 8 compared to 2. So this is also true. Xavier, what about 25% of the populations are robots? It's not true. We had 2 out of 10. This would be if they did their math wrong, and they did 2 out of 8. But that's not out of total. That'd be that'd be robots compared to humans. So this is false or invalid. And 2 out of every 8 members in the population are robots. This is also false because it's not 8. It's 2 out of 10. So it should be 2 out of 10 are robots. We will wrap up there. Tomorrow is your mastery, so please don't lose these. We probably won't pick this up till next week. So be ready for surface area mastery tomorrow, surface area and volume.